single linked list, the format you can observe. The format of single linked list, if you observe, you need to take one node you need to take. You know that a node is nothing but one record. That record technically is called as a node. Yes or no? So here you need to take one node you need to take. That is A. Assume address is A. Maybe you are thinking like 1000, 2000. Instead of 1000, 2000, you are thinking like A now. This is having some information. A node is having some information. So I'm going to scan roll number, name, marks, whatever the things you need, we are going to scan. After that, in this next, this is a field is there, that is address field. Information field and address field will be there. In this address field, we need to store the next student address, next student record address, that means node address. It is holding the B address. This B is having some information. After that, B next address C node is there. The node C we are writing. Then C is having some information. C next 0 I am taking. 0 indicating that there is no records are available. 0 is indicating that there is no records are available. Am I clear, all of you? So if any address is there, then you need to think that there is some record is there. If 0 is there, you need to consider that is the last node. After the last node, there is no records are there. So we need to understand first, in single linked list node format you need to understand. In single linked list node format you need to understand. In single linked list node format, if you observe, now you can see. I'm going to discuss just a second. In SLL single linked list, the node contains two parts. One is data part. Second one is address part. You can note down this. In SLL, the node contains two parts. One is data part, one is address part. Data part and address part. Data part and address part. In SLL, we can add the data in 3 positions. Maybe add at begin, starting position, middle and end position. Whenever you are taking one linked list of single linked list, we can add the node. That means add the data. Data in the sense you can say node. Add the node in 3 positions. Maybe add at begin, middle, end. Anywhere you can add it. In SLL, we can traverse. Traverse is nothing but traveling, moving forward. Am I clear? We can traverse only one direction. Only one direction. Traverse in the sense moving the data from starting to ending. Am I clear? I hope it's clear. Then after that, next if you observe, we are going to take care that in SLL, deleting the data. In SLL, deleting the data also same thing. In SLL, delete a node at begin, middle, and end positions. So now you can delete the node from this double single linked list from the begin position, middle position, and the end positions. In SLL, reverse traverse is not possible. Because of single linked list, it knows only forward direction. It doesn't know who is previous. Previous node address it doesn't know. That's why it cannot travel in reverse direction. Am I clear? All of you? Any doubt in this? So note down these points. The node format, if you observe, node format. If you observe the node format, can we change address? And we need to change every time address. You need to change. Okay. Whenever you are adding, you need to change the address. Whenever you are deleting addresses, you need to change. Am I clear? Node format, if you observe. So I'm going to take a struct node. I'm taking in this node first data part. Data part here, if you observe, in some companies, whenever they're asking, they ask only number. Some companies, they will ask some more details, they will ask. Data part, maybe one member will be there, or maybe n number of members will be there. That is depends on the company, how they are asking. So here we are taking 3 members, we are taking as the data: character, name of 20, then float, marks. This is the data format we are taking. After that, we need the next student address, next node address we need to store. So that's why I'm taking self-referential pointer. I am taking the address name. I am taking next. You can take any name. You can take number, name, marks. These are the 3 data fields, and this is what address part. So this is data part, and this is address part. Am I clear? So this is about a single linked list theory part. You can take the screenshot now completely. I hope all of you completed. Anyhow, I will share this in LMS. You can take the screenshot also. I will share in LMS. This note I will share in LMS. Those who required, you can take the screenshot. Those who doesn't, then you can take it from LMS. I will update the PDFs also, presentation PDFs also I will update after the class. Okay, next. Now try to analyze here. First, we'll start the discussion about creating the linked list we'll create. Creating the linked list means we need to add the records. We need to create the records in 3 positions. But first we'll discuss the position that is begin. Begin in the sense, now you can see you created one record. Right now there is no records are there. One record is created by calling a function. You need to take one function, add at begin. We need to take one function. Whenever this function is called, it will create a node, and after that it is going to scan the data. After scanning the data, we need to provide the links between this. Why? Because malloc function will create the memory. Once malloc function created the memory, it will return that address. By using that address, we need to take it. Here, what I will do in this add at begin function, in this function, I will take one pointer new. By using this pointer, I can recognize which node is created recently. You can take any name. Am I clear? For our convenient purpose, for understanding purpose, I'm taking one pointer name. The name of pointer is new. What is the use of pointer name new means? New is pointing to newly created node address. Recently, the node which is created, it will point. Am I clear? Then after that, next, if you observe, whenever it is pointing this, now you can observe, right now only one record is created. There is no next addresses are there. Next nodes are present. So you need to write next address will be 0 you need to create. Newly created node which is created, next address will be 0. Now, once this function is completed, new is a pointer which is local variable. Local variable means memory will be destroyed for this new. If new variable is destroyed, then this address you will lose. You will lose this address. If you lost this address, this concept is called memory leak. Yes or no? In added begin function, we are taking one pointer, new pointer. This new is a pointer pointing to newly created node. Whenever it is pointing to newly created node, by using that pointer, we can fill this memory. Once we fill, then next address part, if you observe, in the address part, there is no elements are available. So new next address will be 0 we need to write. I already said to you, 0 is indicating there is no records are there after that. Now, once this function is completed, new memory will be destroyed. You need to take this address safely in one place. Otherwise, memory leak will come. Yesterday I said, whenever you are taking train, in your train, first compartment if you created, the first compartment is going to hold by engine. Engine is nothing but one, what you can say, engine is one pointer, you can say that engine is pointing to the first record it is pointing. This first compartment is pointing to second compartment. Second is pointing to third one. Like that, one link will be there between that particular train nodes. So in the same way here also, you need to take one pointer, that is a head pointer you need to take. Head pointer always holding the first record. Yeah. Head pointer always pointing to the first record, first node address it is pointing. Now, right now only one record is there. So head pointer pointing to A next address 0, that means no one is there. Suppose if I want to create again, you are calling the function added begin. Whenever you are calling, new is a pointer pointing newly created memory. That means by using malloc function, you need to create the memory that is B. Now new is a pointer pointing to newly created node address, that is B address it is pointing. Whenever it is pointing to newly created node, now you can see after scanning the data, we need to create a linker. Where you are creating this, our logic is added begin. Begin means always you are creating as the first record. The node which is created recently, you are taking as the first node. If it is a first node, then previous node will become second node. Am I getting? Are you getting the concept? Newly created node, if it is taking as a first node, why? Because it is added to begin logic. Begin means always we are creating at the starting position. So B is the first node now, A will become second node. If B is becoming first node, can you tell me B next address what you will get? Can you tell me B next address what you will get? B next address will be A. Very good. So B, whenever it is pointing to A record, then after that, this is the first node. Head pointer, engine will point to first record. So now you need to change head pointer pointing to B record. Am I clear? Now you can observe here, head pointer is pointing to B, B is pointing to A pointing to 0. That means after A, there is no record somewhere. Now, whenever you called third time, again to create a third link, then whenever you call, one more record is created, that is C. Now, after that, new is a pointer pointing to this particular memory location. Whenever it is pointing, then you need to fill the data. After filling the data, can you tell me what is the C next address will come? C next address will be B. That means it is pointing to this memory. Then after that, you need to change head pointer pointing to first record, that is C. Now you can observe here, if you observe, whenever you are traveling in this head pointer engine pointing to C record you need to print. C next address you need to check, that is B. It will come here. B record is printed. B next address A is there. Then it will come to A. A data will print. Then after that A next to 0, it will stop. Am I clear? So now we need to create the programs in such a way that it should work like this. So first we need to take C record, then next B, next A, like that it should print. This is called added begin. Every time the node is going to create at starting position. Am I clear? Any doubts theoretically? Theoretically, any doubt? So that one of your friends said, so that we can say that head pointer is pointing to latest record. Yes, it is pointing to latest record. One of your friends said all are local variables. These are not local variables, ma. These are dynamic memory. We are creating by using malloc function, that is dynamic memory. Memory will be heap section and you can access anywhere. Now you can observe the presentation PDF. You can observe. Just check it, presentation PDF. The single linked list format will be look like this. If you need, you can take the screenshots. Anyhow, I will share in LMS. Okay. So this is the actual single linked list. You can see head pointer is there, HPTR. It is pointing to the record A. A information is 10 and it is pointing to the next address is B. The node is B. B is having information 20. B next address is C. C having information 30. C next D. D next address is what? This one. So one of your friend asked one question. P10. Sir, previous example that is memory leak. In that we are taking begin function. And for this example also we are using begin function. What is the difference? So same function, sir. I didn't discuss memory leak. Did you observe or not? Memory leak is not there. If new is a pointer, whatever the pointer you are taking, that pointer if you lost, then memory leak will come. But you are safely storing that address in head pointer, memory leak will not come. Am I clear? P10. That's why we are taking head pointer. Head pointer is always, it is holding the first record. So there is no memory leak concept will come. If head pointer is not there, then memory leak concept will come. Now you can observe in this. I'm going to take this slide. You can see here. So here if you observe, first head pointer D, it is created a D and data is 40 and D next to 0. Why? Because there is no address is there, no records are there. Next I am going to create one more record before this. You can see before D, C is created. Now head pointer is changed and it is pointing to C record, C data and C next is D. Before C I am going to create B. You can see it is created B. So B next is C, C next is D, D next is 0. Before this I am creating A. Now you can see head pointer pointing to A. A next address is B, B next to C, C next to D, D next to 0. Is it clear? I hope you clear. So this is the format. First we are going for this head pointer pointing to D record newly created. Before this I am creating C. Now head pointer pointing to newly created node, that is C. C next address is the previous node. And now this is the first. Whenever you created B, it will become second node. So you can see C is become second, D will become third. Before this, whenever I created, A is the first node, B is the second, like this, it is moving forward. In this single linked list, I already said these are the points you need to remember. Self-referential pointer is mandatory. It is holding the next address, and data part maybe one data part maybe one member or 10 members or 100 members. That is depends on you, how you are going to take. Am I clear? Sir, can't we create the node on right side? You can take it right side, left side, whatever it is, but you will get confused, right? Suppose if I'm saying like this, if I'm taking like this data, then address is B. Will it looking good? Is it looking good? Tell me. You can see. Yeah, address is B. Next address is B. Yes, is there. This is the data. But if you observe here, check it here. Which one is comfortable? You can check it. A next address is B. B next address is C. Like this is there. But if you observe, immediately we will concentrate on next address B, means here we will concentrate, but here data is there, here this is there. Actually it is, you can write it, that is up to your wish how you are taking, but node format whenever you are taking, better take it like this. To avoid the confusions and to avoid the conflicts, better take it like this. Address part will be take it at the last side. That is up to your wish how you are taking. Okay. Here first we must create last one like D. Yes, we need to create D. Which address we are taking, that is according to that. Am I clear? Now we'll see. Are you going in a backward direction then? That is backward direction later. How you need to create a direction at last side, that is second. Am I clear? You can see here, I already shown here. You can see the presentation. First D is there. D before if I created, then D will become second. If I created C before, then C will become second, D will become third automatically. Before this, whenever I created a record, then B will become second, C will become third, D will become fourth automatically. Am I clear? Now you can see the programming on this, how to create. Now you can see here what I am doing. Here I am going to take two files I am taking. One is header file. You know that header file contains rules and regulations. So to avoid the conflict and to write the program in good documentary format, I'm going to take two files I'm taking. One is header file, one is normal source file. In the header file, I'm going to take all the rules of the function prototypes, declarations, all the things I will take. Definitions I will take in the file called source file. Am I clear? So VI header.h is the file I'm taking. In this header file, I'm writing the declarations. stdio.h header file I added. Hash include will use malloc function. stdlib.h I am using. I'm going to use exit function. Hash include uni std.h. Hash include if I am using strings concept string.h. Like that, some header files I added. Am I clear? Then we need to create a node struct SLL single linked struct student. I'm taking student information. This student is having int roll number, int character name of 20, float marks. Then after that, we need self-referential structure to hold the next record address, student star. I'm taking the name is next. You can take any name you can take. You can take any name, but I am taking next. You know that whenever I'm going to create a variable for this structure, you need to use struct student, struct student, struct student. Always you need to use the tag name as well as keyword you need to use struct. So to avoid that much complexity, readability format I am going to take that readability format. What I am doing here, I am taking type def. You know about type def. Type def is going to provide duplicate name, alias name for the data type. So I am taking the name is SLL. SLL is nothing but single linked list I am taking. You can take any name, that is up to your wish. UNI std.h is one header file. This is used for exit function. In our programming, I am going to use one function, man exit. Exit is a function I will use. For this function, I am using header file. Am I clear? So that is not required. This is std_lib. Sorry. Okay. Do one thing. Okay, fine. Now clear, all of you? Now all of you clear this? std.io.h, this is for a header file for this, and std_lib.h for I am using malloc function. Then string.h, I am using if string related any functions if I am using. Am I clear, all of you? Okay. This SLL you cannot use in line number 9. SLL is a name you should not use in line number 9. Why? Because once structure is completed, we are providing the name. So line number 9, you should not use it. I hope you clear this point. So stdio.h header file for printf scanf, std_lib.h for malloc calloc if you are using, string.h function, this is header file for strings related information. You cannot use SLL in 4th line. You need to use in 10th line only. Am I clear? Structures completed, sir. I'm not discussing structures concept. Structures completed, type def completed. Yesterday I asked so many questions, sir. Any doubt means no doubt. Now you're asking the doubts, sir. Okay, anyhow. SLL means this is duplicate name. You need to use at line number 10 once this structure is completed. You should not use at line number 9. You should not use at line number 6. You should not use at line number 7. You should not use at line number 4 also. If required, you can use here line number 11. You can use type def struct student SLL. Like this you can use. Am I clear? If you need at line number 11, you can use, and you can use at line number 10. In these two ways you can use it. So I created SLL. So this is the node I created. Now we'll go for the source file. vi sll.c. Don't note it down. I will give the code. Okay. First listen, concentrate here. Header.h main just a second. Now try to analyze. Here, what I am doing. So here header file is added, main function. Now here you can observe. So here we need one header file that header pointer is required, head pointer. That head pointer should be available throughout the program. That head pointer, if you lost, then all the records you will lose. So that's why what you need to do. You need to take head pointer. So head pointer you can take globally or you can take locally. Are you getting my point? Head pointer you can take local variable or global variable you can take, not static. Local variable or global variable you need to take. Why? Because main function means main function once completed, program is terminated. That means throughout the program it is available means main function, inside a main function you can take it. Otherwise, global variable you can take it. So first I am going to discuss with local pointer. Once local is completed, then we'll discuss with global. Am I clear? First we'll discuss local. Once local is completed, we'll move forward with global. So now you can observe here, I'm going to take pointer SLL star head PTR. Head PTR is the pointer I'm taking. Whenever I'm taking head pointer in the main function, you can observe here, head PTR I'm taking in the main function. So it will be available throughout the program. It will be available throughout the program. This address is assumed 1000 address. By default, it will have some garbage value. If I want to say if the records are available or not available, if I not need to check, I'm providing some value that is 0. 0 is indicating that there is no records are available. I'm storing for our convenient purpose. I'm taking 0. 0 indicating that there is no address is there. And here head pointer is pointing to 0 in the sense there is no records right now. Null pointer. Head pointer I'm taking as a null pointer starting. Then after that, we are taking n number of functions and we are going to do so many operations like printing the data, saving the data, adding the data, deleting the data, like that n number of operations we are going to do on this single linked list. So I'm going to take one option, printf, enter your choice, scanf, %LD, address of option. This option I'm going to take. Head pointer is local variable. Why? Because it is declared in a main function. Is it clear? Head pointer is local variable. So it is available in a main function. So now print, enter your choice. I'm giving some options. Printf, one for add begin, add the data at the every time create a node at starting position. This is one option I'm taking right now. Fourth option I'm taking, that is display, printing the data, print node. And after that, what I'm doing, I'm taking one option, 18th option I'm taking, that is exit function, exit, terminate the program. I'm taking some options right now. If option is selected by user 1, you are going to add the record. If option is selected for, you are printing the records. If 18 option is selected, you are going to terminate the program. So if you are taking the options, then that options are available or not, according to that, you need to call the function. I'm taking switch case. Switch case of option I am taking. So here case 1, you need to call add begin function to create the record. Add begin. Break. I am going to take case 4. That is printing purpose. Print node. Break. Then case 18 I am taking to terminate the program. That is exit of 0. Exit is a library function. By using this library function, we can terminate the program. The program will be terminated in middle. Can you use return instead of exit? You should not use return. Return is nothing but control will be moved from function termination purpose. You will use return. Exit is nothing but program termination. Am I clear? In this case, you can use return. Why? Because main function is return means it will go to the underscore start. Problem is not there, but better you need to use exit function. Program termination, you need to use exit. Function termination, you need to use return. Am I clear? If you are using in this case, particularly in this case, return also no problem, but better try to use exit. Am I clear, all of you? Next, I'm using one option, default option. What is the default? If user is given wrong input, then it will come here. Printf, enter valid wrong choice selected. Please read. No. Am I clear? So now you can see these are the first we are going to discuss in today's class. Add begin, print, exit, and this one. And here if you observe, I'm not working only one time. Continuously, I will work it on this single linked list continuously, not one time. After adding, program will terminate. Again, you need to go for again add begin. Not like that. Continuously, I'm working on this. Continuously, if I need to work, I need to go for while one. While one is nothing but the program will execute continuously. When it will terminate means if I given option number 18 whenever I given, then only it will terminate. Otherwise, continuously it is going to work on this. Continuously it is going to ask the options choice from the user. Still any doubt in this? Do you have any doubt? Can I use go to? You can use go to also. Instead of go to, better go for while loop. You can use go to also. Go to is nothing but you need to set the label and you need to go for this. Instead of that, better looping concept is there and better go for loop. Am I clear? You can use for loop also if you need. You can use do while also. That is up to your wish. But I am using while loop. Why? Because it is convenient and looking good format also. That's why I'm using while loop. Next, now we need to add the data. So whenever you are going to add, you are calling one function. The function is what? Add begin is a function. Whenever you are calling add begin function, I already said to you, you are going to create one record and new is a pointer always pointing this. So I'm going to take SLL star new. New is a pointer I'm taking. Once new is a pointer I'm taking, new equal to malloc function. Malloc is a function. It is going to create a newly created memory address, size of SLL. Whenever malloc function you can see, you call the function. User is selected because of file one, it is printing the option. User is selected option one. Whenever selected, it is coming here. Add begin, it is calling the function. Add begin separate stack frame is created. All of you please listen carefully. Add begin is called. Whenever it is called, new is a pointer created by default holding garbage value. Malloc function created dynamic memory, which is created in the heap section. Address I am thinking like a. Assume address is a. Size of SLL means it is a structure. So roll number, name, marks, memory is created, and next is address field is also created. This address you are storing in new. That means you can observe here, new is a pointer always pointing to the newly created record, that is recent record, that is A. You know that one more thing, malloc function is going to return the address, that is type is wide pointer, but new is a pointer SLL type. So better you need to typecast. If you are not typecasting also in C language, it will work. But as per the standard, we need to typecast to pointer type, that is SLL star. Am I clear? Line number 19, if you observe, malloc function return type is void pointer, but here new is a pointer of type SLL, structure pointer. So in C language, without this also it will work. But as per the standard, I am writing a typecasting SLL star. That means I'm converting the void pointer to structure pointer, and this new and this both are same type. So I'm going to store. Do you have any doubt? Maybe you typecasted in C language also. Any doubt in this concept? Till now, any doubt? Okay. Now, once memory is created, in add begin, first we need to remember some point. First is create a node. You need to remember this, create a node. Store data. Fill the next address. After fill the next address, then change the head pointer. Change head pointer. You need to remember this. These are the 4 points you need to remember. So you can see here node is created. A. Storing the data, that means I need to scan the data in that particular node. If I need to store the data in that particular node, you can see printf, enter roll number, name and marks, scanf, %d, %s, %f, address of new arrow roll number. New is a pointer pointing to newly created node. New is a pointer pointing to newly created node. So I'm taking roll number, I'm scanning. New arrow name. Name is an array. That's why I'm not giving the address operator. Array always will give the base address. That's why I'm not taking. Then address of new arrow marks. I'm scanning these 3. After scanning this, you need to fill the address. Now tell me, A next, what you will get? A next, what you will get? Can you please tell me what is the A next address will get? According to your knowledge. A next B. Right now there is no address now. Only one record I created just now. Just now I created only one record, that is A. A next 0 will come. Why? Because there is no data is there after A. Why? Because just now it started. So A next address will be 0. A address safely available in a new. So now I am going for a new next equal to 0. You need to write. New next equal to 0. Am I clear? New next equal to 0. But initially we must assign some valid address to new pointer. Yes, we assigned, right? A16. Line number 19, you can check it. What is line number 19? New equal to malloc function. Malloc function is created the address A. This address is stored in new. That means new is a pointer initially pointing to valid memory, that is nothing but A. Am I clear? Line number 19. Then after that only we are scanning the data. After scanning the data, new next address you will get 0. I'm storing 0. Now tell me, once this function is completed, what will happen? New is a pointer, local variable, memory will be destroyed. If memory is destroyed for new pointer, then what is the address of A? A address will be lost. Yes or no? You will lose this address. This address safely you need to store in head pointer. Then only memory leak concept you can avoid. If this address is not pointed by head pointer, memory leak will come. How can you update head pointer? Head pointer is local variable in main function. Head pointer is local variable to the main function. If I need to modify this head pointer inside this function, this is local variable, not possible to access directly. So you need to go for call by address. Yes or no? You need to go for call by address. Call by value means modifications will not be affected. Call by value means modifications will not be affected. You need to go for call by address. So here I'm passing address of head PTR, address of head pointer. Whenever you are passing address of head pointer, how will you collect? Head pointer is single pointer. Whenever you are passing single pointer address, you need to collect with, yesterday we discussed. Whenever you are passing single pointer address, you need to collect with double pointer. You need to collect with double pointer. So here I'm taking SLL star star head. I'm taking head is a pointer. I'm taking double pointer. Now you can see here, whenever I'm taking here add begin function, stack frame is created. Head is a pointer pointing to 1000 memory location. New is a pointer, garbage value, line number 19, malloc function created a memory. This is holding A. That means new is pointer pointing to A. Scanning the data, roll number I'm scanning 10, name is scanning, then marks is scanning. After that, new next address will be 0, I'm storing. After storing 0, I need to change head pointer. First completed, second completed, fourth one is at last you need to change the head pointer. How will you change the head pointer? Means 2000 star head means you are dereferencing star head equal to newly created node. Newly created node means in head pointer is pointing to the location A. It is pointing. After that, the function is terminated. The function is terminated. Now, whenever it is coming to the main function, in main function, again, option I selected 1. Whenever option 1 selected, add begin function it is calling, stack frame is created. Once stack frame is created, passing address of head pointer, that means 1000. So head is a pointer is created. This one, it is holding 1000 memory. New is a pointer is created. Then next, here garbage value is there. Malloc function, line number 19. Malloc function is creating the memory. It is B. Now new is pointer pointing here at line number 19, you can see. Then after that, scanning the data. So I'm scanning a new roll number, name, marks, all the things I'm scanning. After scanning the details, then new next address, line number 22, you can see. New next, newly created node, this one. New next address, what you will get? Can you tell me? What is the new next address? Newly created node next address, what you will get? 0. You will not get 0. This is starting node. You created before A. You are creating a new node before A you are creating. If you create before A, this is now becomes first record. This will become second record. That means B record next address will be what? B next will be A address you need to get. But here, where A address is there? Where A address is there? A address, how can I access? Where it is available? Where it is available means it is available in the head pointer, not in new. New is pointing to B address. Am I clear? New is a pointer pointing to B. A address safely available in the head pointer. So you need to write in place of new next, you need to write here star head you need to write. Not 0, you need to write star head you need to write. If you are writing star head, head is pointing to 1000. Star means if you dereference this 1000 memory location, you will get A. A is going to store in this B. Then after that, star head equal to new means in this memory location, I modified as a B. It is pointing to B location. After that, it is terminated. Because of this add at begin, again I am taking the option 1 I selected. It is coming to begin function. Head is a pointer pointing to address of head pointer. Address of head pointer means 1000 address it is collecting. Then after that, new is the pointer holding garbage value by default at line number 18. Line number 19, malloc function creating the memory. Memory is created. Then after that, it is holded by new. New is a pointer pointing to newly created, recently created node address. Line number 21, we are scanning the data in the new memory location. After scanning the data, line number 22, you can see new next. New is pointing to C. C next address. Head pointer means now you will get a head. Head star head is nothing but C next will be B. Then star head equal to new means star head. Here we are modifying as a C. After that, once the function execution is completed, memory is destroyed. Now you can see here, head pointer is pointing to C. C next address is B. B next address is A. A next address is 0. No one is there. Is it clear? This is the logic to create add at begin. Always change head pointer. This is previous record. Sorry. Always change head pointer. Next, newly created node. Next address updated. Am I clear? Here is node is created and pointed by new pointer. Now you can see after adding the records, now we need to print. K2 raised the hand. Yes, ma. K2.
Sir, in line number 23, star head equals to new. So whatever assigned to new, like that's SLL star is executed, sir.
Star?
New for new we have assigned SLL star malloc size of SLL.
Yes.
Things will be executed.
Yes, exactly.
Okay.
Why? Because recently whatever the node is created, that recent node is only first node now, acting like a first. So you need to update this recent node in head pointer. So that's why you need to write line number 23, newly created node address we are storing in the head pointer. Clear?
Yes, sir.
Okay.
Thanks.
Now try to analyze. We need to print. We need to print means then how we can print? How we can print means we need to take one pointer. We need to take one pointer. That pointer should point to C record. The pointer should point to the first record. Whenever the pointer is pointing to first record, I need to print first record information. After printing first record information, I need to check what is the node next address. The node next address, if you observe, the node next address is B. B, I need to travel. So I need to change this pointer to next location, that is B. Now, once it is printed, B information, once it is printed, now I need to check B next address, what is there. B next address, if you observe, A is there. A means valid address. I need to change this pointer to next position. Whenever the pointer is pointing to A position, I need to print A record. After printing A record, I need to check the next address. Next address, if you observe 0, now pointer is pointing to 0. Whenever a pointer is pointing to 0, you can say that there is no records are there later, then you need to stop the loop. That means you need to rotate one loop till you will get the next address will be 0, and continuously you need to take it. Once you are reaching at the last position, you need to stop. Am I clear? Once you are reaching at the last position, you need to stop here. Now check it. Now you can observe here. I'm going to take void print node. So here I need the starting address. For this print node function, I need the starting address, then only I can print. So this is only for printing purpose. Printing means you can go for call by value. Explain line number 22. Explain line number 22. Try to analyze once again. Line number 22. One of your friend asked, please try to analyze once again. Head pointer pointing to A. Now tell me, this is A record. Next B is there. B record. Next C is there. C next 0. Where you declared head pointer. Where you declared head pointer means head pointer is declared in the main function. Forgot, huh? Line number 3. Local variable. Am I clear? Now you can see. So if I taken the option 1, all of you please listen once again. If I taken option 1, it will come to the add begin function. So I need to update always this head pointer. This is local variable in the main function. That's why I'm going for a call by address. Call by address only the modifications will be affected. So I'm passing address. It is a single pointer address. That's why I'm collecting with a double pointer. I can dereference 2 times. So here new is a pointer is created. By default, it is holding garbage value. Head is a pointer holding address, that is 1000 memory location, head pointer address. New is a pointer now one creating memory. So whenever memory is created D, now new is a pointer it is holding here. New pointer pointing to D. Now you can see after scanning the records, you can see new next equal to star head. New next line number 22. All of you listen. New next newly created means this one. This is the recent node. You are creating as a first record. Now this previously A is the first. This A now it will become second record. Previously A is the first record. Now A will become second. Why? Because D is added before A. Whenever D is added before D will become first record. D will become first record. So now what I am doing, new next, newly created node next address, A address available in head pointer. So star head you need to take. After that, once updated, I need a head pointer. Otherwise, head pointer will point to A only. So line number 23, star head equal to new means star head, this one, new means D. Now it is pointing here. I hope you cleared this point, R3. New size is 8 bytes. Yes, sir. Exactly. New is a pointer. Pointer size is 8 bytes in 64-bit compiler. Initially, star head equal to 0 inside begin function. Inside begin function, star head equal to 0. You no need to take initially 0 only. Why? Because here you can see line number 3. I given a head pointer equal to 0. Line number 3, I given head pointer is 0. Because of that reason, star head means you will get 0 only. Next, now you can observe, I'm going to printing the data. While printing, I need to take one pointer. The pointer should point to the first record. Whenever the pointer is pointing first record, then only you can travel till last address and you can print it. So I'm going for this print data function, but it needs the address. So that's why I'm passing here. Why? Because head pointer is holding the first one. So I'm not passing the address. I'm passing only call by value. Why? Because just printing purpose. Printing purpose head pointer I'm passing. It is call by value. So head pointer means it is passing address D. So here it is going to collect with same pointer type star head. Now head is a pointer pointing to A. It is call by value. So that's why I'm taking star. Previously add begin call by address. That's why double pointer. First I need to check. Records are available or not. I need to check if star head, if head equal to 0. Head is what? Head is a pointer local variable. It is pointing to this record. Head is a pointer local variable. It is pointing to D. Now I am checking this. Head star head, head equal to 0. If head is 0, then I am writing here printf no records found. No records found. This is the message I am printing. After that, function terminates or return I am using. Here you should not use exit. If exit is used, program will terminate. Here printed node function you need to terminate. That's why I given return. Now I need to print the data one by one. For that purpose, I am rotating a loop. While of first I am checking head. What is head? Head is pointing to A. A is nothing but valid address. That valid address information I need to print. Printf %d, %s, %f. Head arrow roll number. Head is pointing to A record. Head arrow name, head arrow marks. I printed the records. Once I printed A record, first it is pointing to D initially, right? It is pointing to D. D record is printed. D next address will be A. How can you move to the next address? Can you tell me? How can you move to A next? D next. Assign it to new. Where is new? New is not there, right? New is not there. And head PTR++, you should not increment. Head pointer, if you incremented, it is incremented to next position. That is contagious or discontinuous. This memory is not contagious, right? This memory is not contagious memory. We are making like a contagious. It is not contagious. Head pointer equal to head pointer +1, you should not write. It should point to the next address. How will you point? Means in D record, next address you need to check. D next address will be, it is going to give who is the next. So you need to write head next, you need to write. Head next. This head next is what? D next A. This you need to update in head pointer. So head equal to head next you need to write. You should not write head ++. If it is incremented, it will increment to next position. In the next position, the data is there or not, we don't know. Head is a local variable, but whatever the addresses we created, that is dynamic memory. Am I clear? Head next address. Next address you need to check. That is A. A next address you need to check. B next address C next address 0, while of 0, condition fell, terminated. Am I clear? Now we'll check it. We'll check the code. It's working fine or not, we'll check it. We need to add header file. In the header file, we need to add the prototype of the functions. Void add begin is a function. SLL double pointer. Void print node is a function. SLL star. Now compile this. CC SLL.c. It is compiled successfully. /a.out. You are getting 3 options. 18 programming. Sorry. You can see here 18 option I'm taking. Program is terminated. I'm taking this 4 option. Whenever I'm taking option number 4, right now there is no records you created. Just now the program execution is started. If I given option number 4, if I given option number 4, then you can see it is going to print records are not there. You can say no records found. Why? Because recently we didn't added any record. For that I am adding the record 1. 1 means it is asking enter roll number, name, marks. I entered roll number is 10. Then after that name is hello. Then marks is 12.3. 1 record is created. If you want, you can print it. Option I am giving 4. You can see 1 record is there. That record is printed. Again, I am giving the option number 1. It is asking again. I given 12. High 34.5. Again, I given the option number 1 and I am added 13, then good for 56.7. You can see first you created a node. First you created a node 10. Before that you created 12. Before that you created 13. Total 3 records are there. Now this is the first record. It will print first. This is the second record. And this is the third record now. Why? Because we are going for added begin logic. We are going for added begin logic. Now you can see I'm giving 4, then 13, 12, 10 will be printed. You can see record 13, next to 12, next to 10. Why? Because it is called by added begin logic. Because of added begin, so it is taking like this. Any doubt in this? Do you have any doubt in this? Any doubt in this? Now you can see the presentation PDF. You can observe all of you. I think you can able to see the screen. So you can see now. These are actual linked list once you created. It will look like this. First, I am going to take inserting a node at the beginning position always. So first student record I am entered. So add begin logic, head pointer is pointing to 0. So I created a node first, then after that you need to fill. You are going to fill the data. Data is filled. Once it is filled, new next address, you will get 0 right now. Otherwise, you can store this head pointer. Head pointer address is 0. So you can store this. So 0 is stored. Star head. we are storing. After that, you need to change the head pointer. So you can see head pointer is changed. Whenever head pointer is changed, now head pointer is pointing to record A. So it is looking like this. Head pointer is previously 0. There is no records are there. But once one record is created, it is pointing to A. Next, you are going to enter second record. Whenever you are adding second record, then you can see here new node is created. Then immediately you are going to scan the data. After scanning, new next address A will come. A is nothing but it is available in the head pointer. So your return updated new next equal to star head. After that, star head equal to new head pointer should update. Head pointer is updated. So after that, it will look like this. Head pointer pointing to B record. B next address is A record. A next address is 0. There is no one is there. In the same way, I created third record. At that time, memory is created. Once memory is created, immediately you need to scan. After scanning the data, C next address will be B will come. So head pointer is copied. Then star head equal to C means it is updated. Then after that, it will look like this. Head pointer pointing to C node, C is pointing to B, B next is A next is 0. After that, then next if you observe, then here I'm going to point adding fourth record in the same way. It will look like this if I added head pointer pointing to D, D next is C, C next is B, B next is A next is 0. There is no records are there. Now, how can you print? How can you print means this is single linked list. We can travel only one direction. You need to take one pointer. That pointer is pointing to the first record. Then you need to travel in each node and printing the data. You can see just now we discussed head pointer pointing to D record, pointer pointing to D. Whenever pointer pointing to D, you need to print. Then after that head PTR head equal to head next. PTR equal to PTR next means C address is there. It will come to C. PTR equal to PTR next C. C record is printed. After that next address you need to check it is B. It will come to the B next C next B. Pointer pointing to B. B record is printed. After that B next address you need to check that is A. Then while of A condition true, it is printed. Then after that A next address 0. While of 0 condition fail. Whenever condition is failed, the program is terminated. While of 0 condition is failed, so program is terminated. Do you have any doubt in this?